Hello students, welcome to my channel Engineers Academy. Do hit that subscribe button if you haven't done it yet. Now we are going to solve this problem which says that determine the force in each member of the truss in terms of the external loading and state if the members are in tension or compression. Take P equals to 2 kilonewton. And in the second problem it is said that the maximum allowable tensile force in the members of the truss is 5 kilonewton. And the maximum allowable compression is 3 kilonewton. Determine the maximum magnitude P of the two loads that can be applied to the truss. So we have to find the P values for these limits. And so we are going to solve these two problems together, since if we find the solution for this one, we will be able to find the solution for this one. So first of all, we have to find the forces in each and every member in terms of this force P, since it is said that determine the forces in each member of the truss in terms of the external loading. So first of all, we can draw the support forces at A, since we have the roller support. So we will have, let's say, AY reaction here, and at B we have the pin support. So we will have BY and BX in this direction. But as we know that at joint C we have this P external loading, so we can start with joint C, since we have two member forces that are to be determined and we have one known force. So we can start with this, since we have two equilibrium conditions. So from joint C we can start. So let me cut all these members of this truss. So now at C, let's say that we have the CD member is in compression, let's say. So if CD member is in compression, the FCD must be acting towards this joint C. So this is FCD. And let's say that this BC member, this is also in compression. So if it is in compression, its force must be acting on this joint C like this. So this is FBC. So now first of all we have to find the angle of this BC with the horizontal. So now as we can see that if this length is 2 meters and if this length is 2 meters, and similarly if this length is 2 meters and if this length is 2 meters, so this angle and this angle, they are equal, and similarly this angle and this angle, they are equal. So if this is 30, then this is 30. So this is 30 and 30. Similarly, if this angle is 30, then this angle is 30, since both of these angles are alternate angles. So we can say that this is 30, and similarly we can say that this is 30 degree. Now if I draw a horizontal line here, so this angle and this whole angle, they are alternate angles. So if this is 30 plus 30, see this is 60, then this is 60. So FBC is making 60 degree with the horizontal. Now if I resolve this FBC into its components, we will have two components. One of the components is going to act like this, and one of the components is going to act like this. We have this one will be FBC cos of 60, and we will have one component like this one will be FBC sine of 60. So now considering joint C, if we apply the summation of forces along Y, so the summation of forces along Y, that must be equals to 0. In the upward direction is our positive Y direction. So now we can say that this FBC sine of 60, this is acting in the upward direction. So plus FBC sine of 60 minus this P, this is equal to 0, and from this we can say that FBC is equal to P divided by sine of 60. And since we have assumed that the FBC force is acting towards this joint C, and we got the positive sign here, so this means that FBC is in compression. So we can say that this is in compression, and we can say that 1 divided by sine of 60 is 1.155. let's say this is 1.155 P, and this is in compression. This is FBC. So this is FBC in terms of the external loading P. Similarly, now if I apply the summation of forces along X at joint C, that must be equals to 0. Towards the right is our positive X direction. Now we have this FCD in the positive X, so plus FCD, and then we have this FBC cos of 60, that is in the negative X, so minus FBC cos of 60, this is equal to 0, and FCD is equal to FBC cos of 60, and now we know that FBC is 1.155p. So now we can say that FBC is, so now this answer cos of 60, so this is 0. FCD is 0.577p, and as we have assumed that the CD force FCD is acting towards this joint C, and we got the positive sign here, so this means that the assumed direction is right, and FCD is also the compressive force. So we can say that this is the compressive force and this is FCD in terms of the external loading P. Now next we are going to consider joint D. So now at joint D, this FCD must be acting in the opposite direction, since this CD member is in compression. So if it is in compression, this joint is going to apply the force on this CD member in this direction, and as a reaction the member CD will apply the forces in the opposite direction. So we will have that same compressive force at point joint D as well. So FCD is going to act in this direction, that is toward this joint D, if it is a compressive force. So FCD, and FCD is 0.577p. Similarly, let's assume that this BD member is in tension. Let's say if this is in tension, so its force must be acting away from joint D, and we can say that this is FBD. And let's assume that this D member, this is in compression. So if it is in compression, its forces must be acting towards this joint D. So this is this is FAD, sorry, this is FAD. This FAD is going to make 30 degrees. Since this is 30, this is 30, and this whole angle is 90, so then this is also 30 degrees. So we can say that FAD is making 30 degrees with the vertical. So now we can resolve this FBD and this FAD into its components. So FBD will have two components. FBD will have one component in this direction. This one will be the cos component. It will have one component in this direction. This one will be the sine component. So we can say that this is FBD cos of 30, and we will have one component here. This one will be FBD sine of 30, and similarly the FAD will have two components. It will have one component in this direction and it will have one component in this direction. So this is FAD. This one will be the cos component, this one will be FAD cos of 30, and this one will be FAD sine of 30. Now considering joint D, if we apply the summation of forces along X, that must be equals to 0. Towards the right is our positive X direction. So now as we can see that we have this FBD cos of 30, so plus FBD cos of 30, then we have this FAD sine of 30 in the negative X, so minus FAD sine of 30, and similarly we have this FCD, this is also in the negative X, so minus FCD, and this will be equals to 0. So now if I bring this FCD to the other side of equation, it will become positive. So the equation will look like this. This will be equal to plus FCD, and now we know that FCD is this 0.577p. So we can write that this is equal to 0.577p. And now let's divide this whole equation by cos of 30. So if I divide this whole equation by cos of 30, this will cancel out. So FBD, and this is FAD sine of 30 divided by cos of 30, which is actually tan 30. This gives us minus 0.577 FAD equals to 0.577 divided by cos of 30. This gives me 0.666. So 0.666p, and let's say this is equation 1. Similarly, considering that joint D, if we apply the summation of forces along y, that must be equals to 0. In the upward direction is our positive y direction. Now as we can see that we have this cos component of FAD must be acting in the upward direction, since FAD is acting like this. So this is FAD cos of 30 is in the upward direction. So now we have this FBD sine of 30. This is in the negative y direction, so I will write minus FBD sine of 30. Then we have this FAD cos of 30. This is the component of this FAD which is acting in the upward direction, so we will write plus FAD cos of 30, and this P force is in the downward direction, so minus P. This is equals to 0. Now this P on the other side of equation will become positive, so we will have equal to P. And now if I divide this whole equation by sine of 30 minus FBD, let's divide this whole equation by, so this will cancel out and we will have minus FBD and cos of 30 divided by sine of 30. This is plus 1.732 FAD, and 1 divided by sine of 30 is 2p. This is equal to 2p, and this is equation 2. Now if I add equation 1 and 2, if I add this equation 1 with 2, so we will have this. Now we can add both of these equations, so FBD will cancel out since we have minus FBD plus FBD. Then we can add the coefficients of FAD, so 1.732 minus 0.577, so we have plus 1.155 FAD, and we have 2.666p. Now FAD is equal to 2.666 divided by 1.155 p. FAD equals to 2.308 p, and we have assumed that the AD member is in compression. Its force is acting towards that joint D, so we can say that FAD in terms of p is 2.308 p, and it is in compression. Similarly, if we substitute this FAD into this equation, we will get FBD in terms of P. So now from this equation, we can say that FBD is equal to 0.66P plus this term. So we can say that FBD is equal to 0.666P plus 0.577 FAD. And now if I substitute this FAD here, so we will get FBD in terms of P. So let's write that FAD here, this is 2.308 P. 2p, FBD is equal to 2p, and since we have assumed that BD member is in tension, its force is acting away from this joint D, so this is in tension, so FBD is equal to 2p, and this is in tension. Similarly, at the end we will consider the joint A. So at joint A, this AD force must be acting towards this joint A, since the AD member is in compression, so we will have AD force here. This is FAD, and let's assume that this AB member is in compression as well, so its force must be acting towards the joint A as well. So we will have the force like this. So this will be FAB. So now joint A. At joint A we have three forces. We have AY, we have FAD, and FAD is equal to 2.308p, and similarly we have FAB. This is FAB, and this is at joint A. Now FAD is making this FAD is making 60 degrees. If this is 30, this is 90, then this is 60. Or we can say that if this is 60, then this is 60. This angle and this angle both are alternate angles. So FAD is making 60 degree with the horizontal. Now we can resolve this FAD. So this is FAD cos of 60. So this is 2.308p cos of 60, and we will have 2.308p sine of 60. So if I apply the summation of forces along x, that must be equals to 0, considering joint A. This is our positive x direction. So now we have this cos component, this is acting in the positive x, so plus 2.308p cos of 60 minus FAB equals to 0. FAB is equal to 2.308p cos of 60. This gives me 1.154p, and the AB force is acting towards this joint A. So this means that we have assumed that AB member is in compression as well. So we can say that FAB is in compression and its magnitude is 1.154p. So now for the solution of 625, we are given that P is equal to 2 kilonewton. So put this P value in each and every force of the member, and we will get the value for 2 kilonewton. So now here we can say that FBC is equal to 1.155 into 2. This is 2.31 kilonewton in compression. Similarly, FCD is 0.577 into 2. This is 1.154 kilonewton. Again, this is in compression. Similarly, FAD, we can have this FAD. So 2.308 multiplied by 2, this is FAD. 4.616 kilonewton in compression. This is FAD for P equals to 2 kilonewton. And similarly, FBD, this is that FBD. So FBD is 2 times 2. So FBD is 4 kilonewton. This is in tension. And similarly, FAB, this is 1.154 into P. So 1.154 into 2. This is FAB equals to 2.308 kilonewton in compression. So now this is the solution for 625. We got the forces in each and every member for P equals to 2 kilonewton. Now in the second problem, it is said that find the value of the maximum magnitude of P of the two loads that can be applied to the truss if the maximum allowable tensile force is this and the maximum allowable compressive force is this. So now the maximum tensile stress is in BD member. Since this BD member is in compression only, all the remaining members are in compression. FBC is in compression, FCD is in compression, FAD is in compression, and FAB is in compression. So only this BD member is in compression, and its value in terms of P is 2P. So we can say that FBD is carrying the tensile load which is equal to 2P, and the problem said that maximum tensile load is equal to 5 kilonewton. So this will be equal to 5 kilonewton, and from this P will be equal to 5 divided by 2 kilonewton, and this will be equal to 2.5 kilonewton. Similarly, all the remaining members are in compression, and the maximum compression is in this AD member, since this is 2.308 times P. So this means that all the members are in compression, but AD member is carrying the maximum compressive load. So the maximum compressive load is 3 kilonewton. So we can say that FAD is 2.308 P is equal to 3 kilonewton. So from this P is equal to 3 divided by 2.308. 3 divided by 2.308. This gives me P equals to 1.2998, or we can say that P is approximately equal to 1.30 kilonewton. So this is equal to that P force. The external load cannot exceed this 1.30 kilonewton, since if this P force exceeds this limit, then AD member will break, since it can carry the maximum compressive load equals to 3 kilonewton. So this P value is the limitation for those two limits. So if P exceeds, then this BD member will fail first. So the P value must be this one, that is 1.30 kilonewton. This will make sure that the maximum compressive load in BD member remains till that 3 kilonewton. So this is the solution of these two problems. I hope this will help you in your learning. Let me know in the comments if this helps in your learning. Do subscribe Engineers Academy for such more problems from Hibbeler Statics.